Okay, good morning. My name is Pranay Krishnan. I'm the CEO of a small company called Linc. We're a small team of engineers. We're based here in Madrid. We started our journey when we moved to Spain right here in this building, and so it's great, and I can also see some familiar faces who have supported us along the way, so it's great to be here. I'd like to spend just 2 minutes describing our solution, and then spend the rest of the time talking about the very close collaboration that we've had as part of the CLIM Accelerator program. We have basically been trying to solve the problem of connecting buildings and grid networks with the, so to speak, cloud. There are so many solutions that are focused on data analytics, making peer-to-peer energy communities, as we heard earlier. But one of the missing links, so to speak, in all of this is being able to connect it all, to bring all of this data together in one place. And we're not just a software company. We have developed a piece of hardware which can be installed in any type of a building or grid network in a matter of, let's say, 30 minutes if you're an electrician. And what it does is analyze the electrical signal of the building at an extremely high frequency to the point where you can detect every appliance as it turns on and off. And that gives you a very detailed breakdown of exactly where and when you're using your electricity. It also has the capability to serve as a complete building management system, which means you can control and optimize all aspects of the building or grid network. There are two main innovations, let's say, that are the core of our technology. The first is Spectral Analytics. So by that, it's a fancy word, but basically it means we're looking at the electrical waveform, sampling it at millions of times per second, and in that we can detect very unique spectral signatures for different appliances. So it's in a way, it's like we install this device and it gives the building its own nervous system. And we can detect exactly what appliance is working in real time. The second aspect, as I mentioned, has to do with building management. So we can facilitate complete control and data acquisition capability once this device is installed. And just a quick background on my own team. We're a small team of engineers predominantly, but our solution started when we were in university and we developed the solar car. And the objective of this was a race that was 3,000 kilometers across Australia, and we needed to do that purely on solar power. And this required us to develop some fairly sophisticated analytics and electronics, and that's what is the core DNA of the solution. I'd like to switch now, focus to the collaboration that we have. Sorry, this is a bit glitchy. Right, so this is my team together with the team from La Pinada Lab, who are our partner for CLIM Accelerator. We've been working with La Pinada Lab, and we are super inspired, first of all, by their vision, which is to develop a very progressive eco-community which facilitates all of the core technologies that we're here talking about today. For us, this is a huge opportunity, and what we have achieved so far is basically installation of our hardware in their facility. In fact, this was completed yesterday, and we can see real-time data on all of the building systems in real time. We have data coming in on a 1-second resolution, and we can see everything in a great degree of detail. So some of this was a bit too technical perhaps, but I'd like to show it to you anyway. It has to do with all of the electrical parameters, so we can see real-time voltage parameters, the active power. We can see precisely when, let's say, the solar generation started in the morning. We can see all the power quality parameters, the active power, the apparent power, the reactive power, power factors, and so on. And this is critical information if you're trying to develop a sustainable grid. Without having this type of information, you simply cannot connect millions of electric vehicles to the network. It will cause the grid to collapse. And therefore, you need this type of information. It is also useful to enable peer-to-peer energy trading, which is one of our future objectives with this pilot. If you do not know in real time how much energy you're generating, and in that same instant, how much you're consuming, and have levers to match that demand to the available supply, then it's just a pipe dream. So we make all of this quite real. These are power quality parameters. Obviously, we're measuring how much energy is being transmitted. You can see more or less the solar curve since this morning at 8:30. And without getting into too much detail, I'd like to also mention one of our core capabilities, which has to do with the spectral analytics. Now, these colorful lines that you see on the graph represent signatures for every appliance that is active right now at Lapinado Lab. And in this, we can apply machine learning to detect exactly what's using electricity and is there any predictive maintenance problem that there might be. We can detect, for example, if you have a motor that is off balance. We can see that in the spectrum. We can see if you have a high degree of triplet harmonics that would be causing neutral lines to overload. And so this solution is quite sophisticated in that sense. It gives you a great deal of insight. And just as a more sort of representative example, we can see over here that most of the electricity is being consumed at the 50 hertz frequency, but you have these higher order harmonics, which, if left unchecked, will cause a lot of electrical problems in the system. And so there's a lot of talk about digitization, there's a huge amount of talk about electrification, but without the right sort of data, none of that's really possible, and that's what we're here to solve. Thank you.